Hi, Year 11. So, last part of exam 2016, section B, extended response questions. Hopefully, by now you find that the multiple choice questions with your CAS, you're a bit more comfortable answering the questions. Just a quick reminder again, question 16 is a worthwhile one to learn just because of the theory. Question 16, multiple choice question 16, that's a typical question to work on. I'm now going to work on section B, question 1 onwards. There are a few things in this question that I can see some students look at the solutions and may find a bit difficult, and all the fractions and negatives, but hopefully it makes sense as I'm going through it. But even if you're not really, if you're not really good at these, like maybe leave it last and then go on to, like trig functions, circular functions, like these are generally easier to do, and then you can go to exponentials, generally much easier to do as well. So have a go with those questions first, okay? But don't forget as well, you still have transformations if you haven't revised that. You also had counting methods, which hasn't been a great revision on my part there to provide for you guys, but things like combinations, permutations, remembering how to use it when you use it. So if I told you there were 8 people and I want to arrange them, how many different ways can I arrange them? Then how do you figure that out? 8 factorial is the answer. Questions like finding the probability if you flip a coin 3 times, what's the chances of getting exactly 2 tails, and then what's a quick way of finding that out using binomial formula. Do quickly revise those, but even if you don't get these CAS, most of these down, you should be ready for Monday from what I can see, as in like what I'm doing. I'm hoping that I've given enough resources there. But yes, shoot a message if you have any questions, but let me just finish off section B for you, okay? Here we go. Question 1, it says a window frame in the shape of a rectangle with a semicircle on top has a total length of 8 meters. The base of the window is 2r meters, okay? And the height of the rectangle is h meters as shown in the diagram below. Okay, so I got my diagram, 2r, 2r, h, cool. Find an expression of h in terms of r. Well, I remember I told you with applications, every line means something. So it says a window frame in the shape of a rectangle with a semicircle on top has a total length of 8 meters. Okay, so the first thing I need to sort of pick up on is that in order to make this frame, it looks like I need 2r plus 2r plus h, and this outside perimeter, and it's a total length of 8, essentially what it's telling me. So I already know that to find the perimeter, clearly perimeter is equal to 2r plus 2r plus h. But the question is, how do I find the distance on the outside? Now, for those who've forgotten, in year 8 and year 9, this is the outside length of a semicircle. So really, outside length is circumference. Circumference is given by 2 pi times r, or diameter times pi. Okay, and since it's half of it, technically you're doing that. So yeah, technically if you're half it, there's just pi times radius. So pi times the radius will give you the circumference. But the radius right now, the diameter is 2r. Oh, actually, you know what? I'm just going to rewrite it all again. So we had diameter times pi, and we know the diameter of this circle is 2r. So 2r pi. But remember, we want half of half the circle. So it's a semicircle. So I'll write here semicircle. So that means I need a half that. So 2r pi divided by 2. That gives you r pi. Okay, so that tells me that's the distance on the outside, r times the pi. So r times pi, and that will give me the perimeter. So I added h, added 2r, and I added the outside. That should give me the perimeter, and they told me it's a total length of 8 meters. So here we go, 8 equals 2, 4r plus 2h plus r pi. The question wants me to write the expression for h in terms of r, so I need to find h. So if I moved 4r across and I move r plus pi across, then it's 8 minus 4r minus r pi is equal to 2h. Therefore, h has to equal to, divide both sides by 2. This becomes 4 minus 2r minus r pi on 2. There you go. Done. Then hence show that the total area in square meters of the window is given by. Okay, so if you want to find the area, well, area of a rectangle is pretty easy. The area is equal to length times width, which in our case is 2r times h. And then to find out the area of a semicircle, well, area of a circle is equal to pi r squared, but remember you're dividing it by 2. And the radius, since it's 2r for the entire thing, radius is obviously r. R plus r is 2r, hence the diameter is 2r. True? So this is the formula for the area of the top, and I've got the area of the rectangle. Length times width is 2rh. So if I want to find the total area, I'm going to do tot for total. It should equal to the rectangle, which is 2rh plus pi r squared on 2. Now, when I want to show it, clearly it's already looking a bit different here, but I need h to be replaced so they get all r's, because notice the answers are all r's, and I already got h from the previous question. So I'm going to replace this h over here, and what you're going to get is 2r multiplied to 4 minus 2r minus r pi on 2 plus pi r squared on 2. Expand the brackets, and I guess you get 8r minus 4r squared minus r pi plus pi r squared on 2. And it looks like I almost got it. The only difference is I need to simplify these two. And I guess if you really think about it, it's a fraction out of 2. So another way of writing it is negative 2r pi on 2 plus pi r squared on 2. I think I made a mistake somewhere. Oh, it's r squared. There we go. Whoops, whoops, whoops. The reason why is because you multiplied 2r to this, and 2r to that, and then 2r to that, so the r's get squared. And so this works out nicely. 2r squared pi plus r squared pi, that becomes minus r squared pi on 2. It's all fractions here. So therefore 8r minus 4r squared minus r squared pi on 2. And there you go. That works. Okay. Next one, find the value of r for which the area of the window. So again, just going back, even if you couldn't do this question, it was only 2 marks. Use this question here, because they gave you the equation for the area, to answer the next one. Okay. Now it says find the value of r for which the area of the window is a maximum. Now you got the area equation, 8r minus 4r squared minus pi r squared on 2. That's the equation. Now how do you find the maximum area? Again, to find the maximum, remember that occurs when the derivative equals 0. Now there's a lot of ways to do this. You can just, not calculate it, but I mean sketch it on your calculator and then find the maximum. So for me, what I would do is I always define the problem. So define f of x equals 2, whoops, f of x equals 2, 8 times x. I know it's meant to be r, but you know, I like the x's. And plus if you write r, you can't sketch it on the calculator. So make sure to use x's. Here we go, what's that? Pi r squared, so pi times x squared on 2. Is that right? Okay. Defined. Now I'm going to add a graph, and I'm going to type f of x. Okay, this is my graph, and do I expect a cubic graph or a quadratic graph? It looks like it's a quadratic graph. Yes, it is. All right, so this should be all right. And if you're unsure, do menu for a zoom fit, and there you go. That's my definite quadratic graph there. I personally think it's too big, so I'm just going to zoom in, or Control Z brings me back to the same graph. So clearly, now remember, this is a problem where it's an application problem, we were talking about the area. Now, we know that you can't have negative area. Why isn't it printing? Okay, there we go. We know that we can't have negative area, because remember, this is area accessed by radius. Sure? So radius can't be negative either, so you should have nothing on this side, no negative areas. So the only graph part is from 0 to whatever this x-axis intercept is. This is my area. And clearly the maximum is that top value there. So all I have to do is go menu. You can find the maximum value. Menu, analyze, maximum. And let's find the maximum. There we go. Maximum error is 2.872. Does it tell you, what does it say? Express your answer in an exact value. Oh, that's bad, because we just found the decimal point. So the answer is 2.872. If you want to find an exact value, you can't do it through graph settings. So the only alternative now is finding the derivative. Since you know it's a local maximum, then now you just need to find the derivative. And when the derivative equals 0, it gives you a stationary point. You get a stationary point, then you can find the maximum. Okay? So what I'm trying to find is dA dr when that equals 0. That's a stationary point. Okay, so let's find the derivative when it equals to 0. So for me, I define g of x is equal to the derivative. So shift minus x of f of x. Okay, so that's the derivative. And then I do solve g of x, which is the derivative, to equal to 0. I want the derivative to equal 0 and tell me where x is. And it's at 8 pi on 8. Now remember, this is on the x coordinate. I want to find the area. And remember, f of x is the area. So f of, if I substitute this in, when x is 8 over pi plus 8, then technically I should be able to get my area. So 32 on pi plus 8. Therefore, area, max area, is equal to 32 on pi plus 8. Okay. Yes. But I just realized they didn't tell me to find the maximum area. They said find the value of r, which I technically found before. R had to equal to 8 over pi plus 8. I just found the max area. I bet you that's for the next question somewhere. Justify the answer, part B gives a maximum value. Well, you can't justify by saying from the graph. You actually now have to use a sign diagram. So using a sign diagram, when this is r, you got r is equal to 8 over pi plus 8. And you know the gradient 0, so dA dr is the gradient. It's 0. Now you just got to pick a number before and after. This is a bit tricky because we don't know what 8 over pi plus 8 is equivalent to. It's 0.7, so a number after that, before and after, you can pick the number 0. This is just to get the gradients, okay? I know it's not part of the domain, but 0 and 1 would work. Okay, and it just makes it easier to solve. So if you sub in 0 into the gradient formula, and what's my gradient? It was g of x, so g of 0 is 8, so that gives me 8. So that's a positive gradient. And if I sub 1 in, g of 1 gives me a negative pi, so negative gradient. So therefore local maximum, as you can see. Now we knew it from the graph, but you have to show it using a sign diagram. Okay, at r equals to 8 over pi plus 8. Okay, now find the maximum area of the window expressed. Now we already just did that. I did it a bit of ahead of time. So max area was equal to 32 over pi plus 8. Okay. Find the height of the rectangular part of the window when the area is a maximum. So pretty much when the area of the maximum is 32 over pi plus 8, then you are meant to find the height. Now the height, we had it over here. That's your height. So find the height of the rectangular part of the window when the area is a maximum. So you know that when r equals to 8 over 8 plus pi, that's when you have the maximum area. And you know that height is equivalent to 4, what was it again? Minus 2r minus r pi. Okay, so minus 2r minus pi r on 2. And therefore you can sub it in and find out, sub r in and find out what h is equal to. Now in my CAS, I'm just going to type it in. It was 4 minus 2 times, and what was the number again? It was 2 times 8 over pi plus 8, and then minus, this is a bit tedious, isn't it? Pi times r. Now what's r again? 8. Oh my god. Let's do it again. Here we go. 8 over pi plus 8 over, what was it again? 2. 16 pi plus 8. Okay, so that's the height expressed as an exact value. Okay, cool. So I got that. Now, there are a couple things to be careful about. When we're doing this, especially for the next question, you have to be mindful of the domain in terms of height and radius. Now, the radius can only be up to 8 over 8 plus pi. And so since my domain can only be between 0 to 8 over 8 plus pi, what you have to make sure is this graph accounting for that? Because that's my domain, true? So what you have to make sure now is, and this usually, a lot of times, I did this for the quadratic sac as well, but a lot of times we overlook this problem. We don't check if h and r make sense as well, because height can only be positive and radius can only be positive. So I would now define a new graph, and I'll go define h of x is equal to 4 minus 2 times x minus pi x, pi times x on 2. Okay, now if I actually sketch this graph, okay, so we just go, I'll just do another new graph. Here we go. Add graphs, h of x. This is my graph. Now, there's a bit of a problem. Remember the domain for this graph, this h of x, we said the domain has to be between 0 and 8 on 8 plus pi, because that was the, that was the maximum radius that you can have, okay? So what is, we need to work out what the radius can be. Now the radius obviously ends up stopping here. You can't have negative height, so I'm just right here. You can't have this section down here, this whole bottom part here. So if I just highlight it, this section here is when the area, I mean not the area, the height is less than 0. That doesn't make sense. In our problem, it doesn't make sense. And then also, your radius can't be less than 0 either. So all of this is gone too. So that means, what is your domain? The only acceptable domain here is between r to whatever this point is. Now to find that, that's when height is equal to 0. So you can go back to your calculator, which is over here. You can say, whoops, what am I doing? Cancel. I want to solve for the y-intercept. So, I mean the x-intercept. So find x when y equals to 0. And now you got 8 over pi plus 4. So what that tells me is in your graph, which looks like I closed it. Or did I close it? No. Sorry, I'm just going to delete this. How do I edit, delete? No? Do another one. Okay. What I just found out is the x-intercept here is 8 over pi plus 4. So that means my suitable domain can only now work between, from here to here, is 0 to 8 over pi plus 4. Okay, which is a bit troublesome because remember our radius before was, the maximum was at 8 over 8 plus pi. Now I don't even know if that's within the domain or not. But if I were to sketch this graph, I know that this graph has a maximum up until r is only between 0 and 8 over pi plus 4. Since I want h to be greater than 0 and r needs to be greater than 0 as well. Okay. Now that I've got the restriction, this is going to be tricky because your domain initially for A, we haven't actually worked out the domain, but whatever the domain is, we have to remember that restriction is 8 to pi plus 4, 8 over pi plus 4. That's for radius to work with the height, and we need now radius to work with the area. So if we go back to our equation, f of x was our answer. So f of x is equal to, so let's find out the x-intercepts for the area. And what you get is x is 0 to 16 plus 16 over pi plus 8. So what I'm saying is this is the area graph, and the domain for this one is from 0 to 16 over pi plus 8. But remember, if this is the radius, radius is now 16 over pi plus 8. This works for the area. But what about height? Height, we said that r can only be between, what was it again? It was 8 over pi plus 4, I think it was. We don't know if this is smaller than that. Because if it is, that means that the graph is restricted now. Okay? So, first thing we're going to find is 8 over pi plus 4 bigger or smaller than 16 over pi plus 8? Okay, so let's work out what 16 over pi plus 8 is. So let's work this out. 16 over pi plus 8. That's 1.43, whereas the other one, which was 8 over pi plus 4. So yeah, so that means the domain of r can only be up to 1.12. So that means when we sketch our graph, it doesn't go all the way up to this point. See, this point was where it's 1.43. We said that the radius can only work for the height. If I want the height to be positive and the radius to be positive, the radius can only be between 0 to 8 over pi plus 4, which is 1.2. 1.2. So it can only be up to this point. So that means the graph has to finish somewhere like that, essentially. It doesn't hit the x-axis. So when I'm sketching it, remember it's going to be 0, it comes back up, and I need to know at 8 over pi plus 4 what the endpoint would be. Okay, so what is this endpoint? Now, remember, because if I continue the graph, then it would have been at 16 over pi plus 8, but that can't work, because if that's going to work for r, then height would be negative. That's the problem. Okay, so I know it's a bit confusing there what I'm saying. It's more about this restriction here that I need you to focus on. This section, whoops, why does that happen? What I'm trying to say is focus on this section. In order for the height to be positive, the radius can only be between here. Okay, it couldn't have taken the full length for the area, which is 16 over pi plus 8. That wouldn't have worked for us. Okay. Anyways, we worked out that when r is the maximum, that occurred when it was 8 over 8 plus pi. And this is 8 over 8 plus pi. And the max area, which we figured out before, was 32 pi plus 8. Okay. I know this is when it's 0, 0, but you can't have area being 0 and radius being 0, so it's an open circle. And then now to find the endpoint where the radius, remember the radius has been restricted, so at 8 over pi plus 4, I need to know what the area is, and I can do that by going to my CAS. F of this gives me 32 pi over pi plus 4 all squared. Okay. There you go, and that's my graph. So I think, if I remember correctly, in that year, a lot of students would have drawn it all the way down, and that's because they didn't pay attention to the restriction of R and H. Okay, because remember, you have three variables here. You have R affects H, and then R also affects area. So if you want area to be greater than 0 and R to be greater than 0, we had a certain domain for this. But then we also had to make sure that the domain for R also fits with this one as well. And obviously this one was our victor in the sense that it fits in both conditions. So that would probably have been the hardest part of the question. The rest should have been all right. But let's move on so that you don't feel too motivated. Okay, let's do this question. This should be easier. Here we go. It says, on a tropical island, the outside temperature on a day in February can be modeled by the equation. You've got a trig function. T is the temperature in degrees. T is in hours after 2 a.m. So that's a keyword. State the maximum minimum temperatures on this day. So, like, if you knew the cost graph, that's technically up by 29. It's reflected and an amplitude of 6. I can already picture the graph in my head. I'm sort of like, well, up by 29. So up by 29, and it's reflected, so it should look something like that. Okay, and the period is period equals 2 pi on 12, which works out to be 24. Okay, so the period is 24, and it's in hours, so this is a 24-hour period, and the amplitude, so if I cross through the center, the center is at 29 because it went up by 29. Maximum is 29 plus 6, so the maximum is 35, and minimum is 29 minus 6 is 23. Okay, that's my visual representation of what the graph looks like. So obviously maximum and minimum temperature is 23 and 35, because 29 plus 6 and 29 minus 6 will give you the minimum maximums, right? But just in case that you still haven't really got the idea of picturing it, you can use your CAS, and I'm just going to teach you how to use your CAS here. We're going to define it. Okay, so I'm going to delete all of this again. Define f of x is equal to, let's say, 29 minus 6 times cos of, here we go, pi times x over 12. Now, I would put in a domain, but does it have a domain? No, it doesn't have a domain, unfortunately. Okay, so there we go. Now I'm just going to go to my graph, type f of x, and I don't see it. And it makes sense because remember the graph shifted up by 29 and my highest y value is 6.67. So again, how do you do it? Menu for A, zoom fit, see if it fits. Oh, nice and lovely. Maybe I would want it to be a bit more sort of zoomed out a bit. So what I'm going to do is menu for 1. The X values, remember it was up to 24, so maybe I'll do 50 for 2 days. And the Y values, let's, instead of going to 21, let's go down to negative 10. There you go. Actually, maybe I should just shift it up a bit. There we go. So this is my graph. Okay, I'm going to delete the f of 7. F of 7 is, I don't know which graph is which. Delete. Okay, there we go. This is my red graph, and don't worry about this coordinate. I don't know what this coordinate is for. It must have been from the previous question. But this is my graph, and if you want to find the maximum minimum, well, you can just go menu, analyze maximum of this graph. So maximum, and I was right. Maximum, the Y value is 35. And then if I want to go to minimum, menu 6, minimum of this graph. Oh my God, come on. 23. Okay, so like I said, it's shifted up and it starts at a minimum, goes to the maximum, back to minimum. So the center is up by 29, and then amplitude is 6, 29 plus 6 and 29 minus 6 is how I knew. Okay, but there you go. So max temperature is obviously at 35 and minimum is at 23. Okay, get your amplitude plus and minus 6. Hence, what is the average outside temperature? Well, the average is the center. So even if you didn't know that, you can do 35 plus 23 divided by 2, and it will give you the average anyway. But remember, I drew the graph for you, and I said, well, normally a cost graph would look like this, where it's from -1 to 1, and the center is at 0. But since you're adding 29, 29 means up 29. I knew the 0, the center goes all the way up to 29. And the max became, 29 plus 6 became 35, and then minimum was 29 minus 6. That's how I knew what the graph roughly looked like. But the average would be the center, which is 29. Anyways, now what times does the maximum temperature occur on this day? Well, we know that T hours is after 2 a.m. Now, from the graph, clearly we're only working with this right-hand side. So from 2 a.m., the first time, maximum temperature is right up here. And I already got the coordinates before. It was 12:35. Now, remember, 12 is the number of hours after 2 a.m. So at what time? It says at what time. Now, since it's T equals 12, it's 12 hours, right? Then 2 a.m. plus 12 hours will give you now 2 p.m. So 2 p.m. is when you first reach your maximum temperature on the day, okay? What is the outside temperature? And because it's on this day, in a day there's 24 hours, so 2 p.m. finishes there. What is the outside temperature at 9 a.m. on this day? So from 2 a.m. to 9 a.m., that's a span of T equals 7 hours. So really, they're just asking what the temperature is. What is the temperature if T equals 7? So now, equation, since we defined it, we can just go back now and say, well, F of 7 is at 7 hours. Oh, F of 7 is 30.55. It says give correct to 1 decimal place, so 30.6 degrees Celsius. Okay. Next question, when the outside temperature reaches 30 degrees, so now it tells you the temperature. Marina closes the shutters on the windows to her house. The shutters remain closed until the outside temperature cools again to 30 degrees. Okay, so what is the first time that the outside temperature reaches 30 degrees? So your case here, f of x is the temperature, so you're just really saying if the f of x is equal to 30, so the temperature equals 30, find x, which is the time. Okay, and this is going to give you infinite solutions because you don't have a domain. So you see, if I put enter, you get really weird answers. Now, we know because they're talking about a day, day starts from 2 a.m. to obviously 2 a.m. again. So it would be 0 to 24 hours. So in my case here, I would then put a domain. I'll say given that it's between 0, x, so the time is between 0 and 24 hours. Now I can get an answer. There we go. So press Control Enter, by the way, to get the decimals. Otherwise, you get these weird answers up here. So that tells me that at 6.639 is the first time I will reach a temperature of 30. So here it says, what is the first time that the outside temperature reaches 30 degrees? Correct it to the nearest minute. Well, this is 6.639 hours. So 6.639 60455. This is in hours. How do you change hours to minutes? Well, you already know it's 6 hours. You just need to know if 0.639 60455 what it's closest to. Now you times it by 60. Minutes times 60. Ooh, sorry, is it times 60? No, this is in hours. So if it's 0.5 hours, times it by 60 to change it to minutes. And that tells you it's 38 minutes. So the closest minute is 6 hours and 38 minutes is technically the answer. So, but it asked you for what time. So I know that time was 6 hours and 38 minutes. But since time was from 2 a.m., then 2 a.m. plus 6 is 8 a.m. So that's 8:38 a.m. is the time. Okay, when you first reach temperature of 30 degrees. Next one, for what percentage of the day, corrected 1 decimal place, are the shutters on Marina's house closed? Now, they said Marina closes the shutters on the windows to her house, and the shutters remain closed until the outside temperature cools again to 30 degrees. So once it reaches 30, if you think about the cost graph, it goes up and it goes down. The graph reaches 30 at some point, okay, and then it shuts. It shuts, and then by the time it remains shut up until it reaches 30 again. So this is the time. I found out it was 6.6 something. I can't remember what the answer was, and there was another answer which I didn't look at. This is the time frame in which they were closed. So if it's out of 24 hours, I just need to know how long it was from 6 point something to the next number of hours. So let's have a look. It was between 17.36, so I'm going to write it here. 17.36039555. Take away 6.63960455. This gives me the time difference. The first time and the second time, how long were they, like, obviously above 30? It was clearly from this direction or this time. It's 10 hours and 10.72 hours. So in my case there, I would want to know the duration, and the duration is 10 they wanted the percentage, sorry, 10.720791 out of 24. So if I just took this answer, divided by 24, and that gives me 0.446, so about 44.7% is the percentage of the day, okay? Because that's, if you times this by 100, there you go. So this is, for those who are confused, this is the time at which I calculated on the bottom here. I worked out how long did it take. So I'll draw it again. I was working out how long when it was from the first time to the final time. It was 6.63 and this was 17.3 something. So I know that from here onwards, from this time, between this time, that's when it's shut. Okay, and it only opens again when it cools down. So this is the period of time over a course of 24 hours. So I know I needed to find out how long it is between 6.63 to 17.3. I worked out that to be 10.72 out of the 24 hours, divided by each other times by 100 gives me the percentage. Okay, so 44.7% of the time it was closed. Okay. And that was question 2. Now I can see the last question being a bit difficult there. But you know, let's move on to the next one. Last question. No, is it the last one? Yes, it is. Okay, here we go. A former mine site is to be developed into a housing estate. The mine site is to be filled with material which must be pressed down before building can begin. Okay. The height of the proposed soil material, S in meters above the base of the mine, T years after it is placed there, is modeled by. Okay, so I've got this equation again. First thing I would do, define. Okay, when I read a question, I just define it. So define f of x equals 2, 17.5 times 2 to the power of negative 0.1 times x plus 20. And there's a domain greater than 0, so given that x is greater than, is it greater than or equal to? Greater than and equal to, okay, 0. Okay, there we go. So that, I've defined it. Now let's answer the question. Find the initial height of the proposed soil. Okay, so obviously t is the time in years. Now the initial means when it first started, so t equals 0. So when t equals 0, find s of 0, because s of t apparently represents the height. Okay, so I'll just go back and do f of 0, and it's 37.5 meters, I'm assuming. Is it to say? Yeah, it says s is in meters. So height of the proposed soil, s is the soil, so height of soil is 37.5 when it's initial. 1 mark, easy. Sketching the graph. Now, for me, I can already see this is an exponential problem. There's a negative next to the x, and so it's a reflection in the y-axis, and there's an asymptote at plus 20. So in my head, I already got a graph that looks kind of like this at s equals to 20 is the asymptote, and I know that it has to come down like this. That's the most obvious part of the graph at the moment. It said t is equal to 0, so that means this is an endpoint. And we worked out it started off at a 37.5 meters in height, and it goes down and it approaches 20, obviously. But that's for me, because I can read the graph. But if you can't, then you can just type in the function, which actually is just right here. Most students will probably miss out on the asymptote, so don't forget the asymptote when you're sketching these. Okay, there's my graph. And we know that the y-intercept when t equals 0 is 37.5. So there you go. That's my graph there. So let's go back to the function. So there we go. That's my question. Over the long term, okay. Obviously, over the long term, it's clearly approaching 20. The asymptote is at 20, so it's clearly 20 meters. Next one, we're almost there. Just a couple more questions. So here we go. In theory, the height in meters of the material that is used to fill base after years placed, has that changed? Oh, now it's negative kt. Okay, so I'll probably define a second one. Define g of x is equal to, and I'll do all the same. The only difference is I'm going to change this to negative k and remove the define, so delete, delete, delete. Define g of x is equal to that, where x is greater than or equal to 0. Yes, is that all the same? 17.5, negative k. Okay, cool. Enter. Okay, so that's what g of x equals to now. Now, it says k is a positive constant. K is a positive constant. Depends on the type of material that it is used as fill. In an effort to have the fill in the mine compress more quickly, a crushed rock material is being considered. Okay, so you got crushed rock. It is known that crushed rock will have a height above the base of the mine 24.375 meters after 5 years. Okay, so what they just told me is when t equals 5, so after 5 years, the height, or h of t technically now, is equal to 24.375. They've just given me a coordinate, and I can use that to find k. Oh, but they want me to do it algebraically. Okay. See, if I were to use it on a CAS, at that point I would have said solve g of, and it was 5 years, equals to 24.375. Solve for k. And that would have been able to give it. So obviously the answer is 0.4, but we have to show that it equals to 0.4. So let's do this now. So height of t is equal to 24.375 is equal to 17.5 times 2 to the power of negative k times 8, because 8 is the time, plus 20. Solving it, minus 20 on both sides, so now that becomes 4.375 equals to 17.5 times 2 to the power of negative k times 8. Divide both sides by 17.5. This cancels out, so you get 2 to negative k times 8. And what's 4.375 divided by 17.5? 4.375 divided by 17.5 is a quarter. Oh, that's nice. So it works out to be a quarter. And that means I can write this as 4 to the power of negative 1 to negative k times 8. And 4 can be broken up into 2 squared to the power of negative 1. So 4 negative 1 is 2 squared negative 1 equals 2 negative 8 times k. And that's the same thing as writing -2 on the power. So now the bases are the same. You can say that the powers are the same because it's equal. So therefore -2 equals to -k8 and divide negative. So 2 equals k times 8. Divide both sides by 8. And so 2 on 8 equals to k. And that's 1/4. Have I done something wrong? Didn't we have an answer of 0.4 before? 0.4 is not a quarter. What did I do wrong? I've obviously done something wrong. -2. Oh, that's my mistake. I wrote 8. Where did I get 8 from? Oh, this looks like an 8. It's a 5. Okay, it was 5. Whoops. Okay, so that was 5 times 5. Good thing I checked with my calculator that it was 0.4. So times 5. It was all times 5. This should be 5 here. This should be 5 here. So all this should be 5. Okay. 5, 5, 5. So 2 out of 5, which is actually 0.4. Okay, cool. There you go. That was my mistake. There you go. Bad handwriting. Terrible handwriting affects your solutions. Okay, so k equals 0.4. That makes sense. Another type of material that contains recycled tires is known to compress down more quickly than the soil material in part A, but more slowly than the crushed rock material described in part D. Find the possible values of k that this type of recycled material would have. Okay, so you got another type of material, and this is the interesting thing. It says, remember, to compress more quickly, k had to be 0.4, right? And it had to be crushed rock. Whereas if it was 0.1, when k is 0.1, then I think that's the norm. That's how it was, yeah. So it was the norm. So it was 0.1 to 0.4. But then now it tells you that another type of material, we don't know what it's called, so it's not crushed rock, and neither was it whatever this one was. It was soil. So it's not soil and it's not crushed rock, but it is known that it compresses down more quickly than the soil material, but more slowly than the crushed rock. So crushed rock was 0.4. That was really fast. So over here is fast. But then slow is when it was 0.1. So obviously the material has to, k has to be between these 2 points, from 0.1 to 0.4, for it to be faster than the slow, so the soil, but slower than the crushed rock in part D. That would make sense. Okay. Now use the respective models for the height of the materials to find how much higher the height of soil material described in part A will be compared to the height of the crushed rock material described in part D when t equals 10. Well, part A, I had it as f of x, or technically it's s of t, and I want to know when t equals 10, what is the height equals to, and then the next one was height of t, h of t, so crushed rock, when t equals 10, find out the height. And if I want to know the difference, because they're saying compared the height, express your answer in meters corrected 1 decimal place, how much higher? So really just find the heights and then subtract them. So it's a long-winded way of saying f of 10 is 28.75, and then g of... Did I define it before? No, I didn't define g. I gotta define g. G was, we found this to be 0.4 for crushed rock. So g of 10 is 21.09375. So 28.75 is for the soil, which is the f of x, and then g of x, which is the crushed rock, which we worked out was 0.4 for k, and that's 21.09375. Now, to find which one's how much higher, well then it will just be s of t minus h of t, which is 28.75. Take away this answer, and that gives you, round to 1 decimal place, is 7.7 meters. There you go. Done. Last question. Woo! When the height of the fill material reaches 21 meters, okay, above the base of the mine, it is considered safe to be built on. How much time will be saved in preparing the site to be built on by using the crushed rock material? So we want the crushed rock, and I named it as G of X before. Describe part D compared to using the soil material described in part A. Express your answer in years correct to 1 decimal place. So they're now telling me that when the height is 21 meters, it's considered to be safe. Now, how much time will be saved in preparing the site to be built on? So basically, I need to know what is the time when S of T reaches 21 and above, and what is the time for the crushed rock material to reach 21. Okay, so yeah, that's pretty easy. We're just simply working out for the time for S of T and time for H of T, and then see how much time we've saved. So T1 minus T2. So I'll just call this T1 and T2. So let's find out how much time is saved. So solve for f of x to equal to 21. This is for the soil. That tells me it takes 41, so time T1 is equal to 41.2928.302 time 2, which is the crushed rock. So how long does it take for the crushed rock? So solve for G of X equal to 21, and it's 10.32, so 10.32 32075. Notice that I'll take as many decimals as I can because I don't want to go wrong when we correct our final answer. And technically time saved would have to be T1 minus T2. So this is what I'll do. I'll just do this minus, I don't know if I can do that. No, it doesn't work. I have to take away the x's. Okay, delete the x's. There we go. And it's 30 point, and they said express your answer in years correct to 1 decimal place, so it would be technically 31 years. It's 30.96 years, but then that becomes 31 years. That's how many years that you would save, because that's how long it takes for the soil to reach 21 and then safe onwards, and then it takes 10 years for the crushed rock, so together it's 31 years. But there you go, exam 2. Now, just a reminder again, if you're doing extended response, I want you to really look, multiple choice, really look at question 16. But that concludes my paper for today, 2016. So you got exam 1, multiple choice question, and extended response questions. All done.